So as part of my role in the IoT business unit, I'm responsible for SD-WAN, Cisco IR 1800, which is a ruggedized router platform, as well as Cisco Secure remote access platform for industrial. So today we're going to talk about IoT, but more specifically, I don't really like the name IoT, industrial IoT. So that's going to be those industrial IoT customers, the utilities, grid automation, distribution, wind farm, solar panels, moving vehicles, and things like that. How does SD-WAN relates to that space? And that's what we're going to talk about. Traditionally, at Cisco, we've always been positioning traditional network management solution, but we are moving towards SD-WAN manager, Catalyst SD-WAN manager, not Meraki SD-WAN. We have two SD-WAN at Cisco because we like to make things fun. So let's see how it works. First of all, SD-WAN for industrial IoT, what does that mean? Why do we do it? Because we want the operations to scale. We want security. We want ease of configuration. The industrial IoT customers are not usually using bleeding edge technology. For them, what is really important is availability. When you have a supply chain, when you have a manufacturing plant, you are ready to balance a little bit of the security to make sure that your networks keep running all the time. So they have different requirements than enterprise. They have different architectures, and we have traditionally not positioned SD-WAN for those customers. But let's see, fundamentally, let's go back at the basics of what is SD-WAN and why SD-WAN is relevant for those customers. And that's a shift in Cisco's IoT business unit strategy that I want to talk about. So SD-WAN is not new, right? I'm not here to talk about SD-WAN and tell you this is the best thing about after a sliced bread, even if I think it is. Originally, we started to support SD-WAN on the IR 1100, the small ruggedized platform in 2018 or 2019. And as things go, we expanded the support on the other platforms. But SD-WAN is not new in absolute terms. SD-WAN is built on top of YANG models, is built on top of netconf to do the configuration, which is not typically what traditional management platforms are doing. They are using SNMP or CLI-based configuration, which are prone to have a number of different issues. Then we started working on TailF, which is the early version of that. And we acquired Viptela, which was really when things started to change. Viptela became vManage. vManage became SD-WAN Manager. And there we are today. Not a new product, but it's new in the industrial IoT space. The reason why it's new is if you look at some of the verticals that we are working on, solar panels, water utility, electricity distribution, roadways, intersection, ambulance, fire trucks, police departments, all these things relate to IoT and do require a number of features that are key and fundamental to SD-WAN. Like, for example, auto VPN, the ability for SD-WAN to create tunnels everywhere, to create an overlay fabric. We'll review that in a moment. Some of them do require advanced routing, but not necessarily all of them. Security, top of mind. It is not a week without hearing a story about someone being hacked, particularly OT networks, because it's so easy to get in, right? And once you get in, it's old system, unpatched system, because they have an old conveyor belt that is still running Windows NT, and I swear it's true, it's happening in the real world. So for them, security is very, very important. Okay. Last but not least, if you compare what we do here in the IoT space versus what we do in enterprise, for us, cellular is primary link. It's a primary uplink. For most of the remote sites, the only way of getting connectivity is cellular. In enterprise, it's always a backup. There is always a primary option, and we use cellular just in case you lose the network. So the use case is slightly different. Is SD-WAN 100% ready for that? We're getting there, so that's something we are really actively working on, changing some of the features and also enabling some different modes, but I'll talk to you about that in a few slides. I just want to make sure everyone's on the same page. I like to do that and go back to the SD-WAN fundamentals. What is SD-WAN? It's a new way of operating your network. It's not just a new application, it's a new way of operating the network if you compare it with a normal autonomous iOS XE platform where you configure stuff in the CLI. It is very different. You have to forget your old configuration habits. I can't relate how many times I've been to a customer and you say, well, I like to do this little script because when I lose one interface, I use an IPSLA test and an EEM script to switch over to the other route. No, don't do that. This is not what you need to do in SD-WAN. SD-WAN will take care of that for you. It's part of the fundamental way of the fabric, how the fabric works. So don't start with an existing configuration. We've seen too many times customer thinking an existing config and say, well, the same config in SD-WAN. It doesn't work the same way. You cannot just take a config and make it SD-WAN. It's just a different concept. It works differently. I hear very often SD-WAN is complicated. In my opinion, it is more complicated for someone that knows very well network management because they have to unlearn most of the habits that they have. I like to say SD-WAN is different. It's not more complicated. It can be complicated, don't get me wrong. It can be very complicated. But for us, for the Industrial IoT, it simplifies a lot of things. It can be very simple, in particular thanks to this ability to auto VPN with different sites. What is sometimes very cumbersome for newcomers or even people that are very familiar with the matter is the vocabulary we use with SD-WAN. So I'd like to clear out some of that. What is the underlay in the SD-WAN world, or what we call the transport or VPN 0, all those things are essentially the same thing, is the layer 3 communication between endpoints. So you got your edge routers, and they have somehow a way to talk to each other using IP. You don't have to do rerouting or anything like that. Those IP links can fail. It's not a big deal. You just have plumbing to have basic plumbing in place. That is what is going into the iOS XE configuration. So this underlay is very basic, and there is really not much to say. This is not where you do QoS. This is not where you do dynamic routing. This is just the basic plumbing. Then you have service VPNs. That's a new notion of SD-WAN. This is where your customers, devices, PLCs do reside. It's more like a VLAN, for example. So if I am a customer, I may have two VPNs, one for my machines, my PLCs, and one for my users who do get access to the corporate network and to the internet. But my PLCs do not get access to the internet. The service VPN is fundamental to the way SD-WAN is working because it provides natural segmentation. In this diagram here, we have two VPN. We have VPN 1 and VPN 2. All the VPN 1s will be able to talk to other VPN 1s on all the different edge, but not to the VPN 2, and they cannot go to the internet unless you configure it. But by default, we provide isolation versus the transport, isolation across VPNs, and that is giving you a de facto security. It's security by design. It is secure by design. I got this question often, hey Manuel, how to do segmentation in SD-WAN? If you do nothing, you get segmentation. That's the beauty of it. It's just the way it works. How do you connect those sites together then? Because we have the underlay, basic IP connectivity. We have service VPNs. So how you connect the service VPNs together, it's thanks to the overlay. The overlay does not use normal iOS XE routing. The overlay runs in software on top of the normal router and is building a software fabric. I will talk about the fabric later. But the fabric is a bunch of IPsec tunnels that are going to be formed between the edge routers. Well, that's perfect for our IoT use case. That's exactly what we want. We want those routers to communicate with each other or communicate with a hub with no configuration whatsoever. Who has ever tried to configure IPsec tunnels manually? Yeah, I see your face. You've done that. It hurts. With SD-WAN, it's done automatically. The keys are rotated automatically, and you don't have anything to do. That's, for me, that's the beauty and the applicability. And then when the fabric runs, which means when all the tunnels are formed, you got all those different VPN layers that are naturally isolated. You can say, I want VPN 10 to talk to VPN 20. You can say VPN 20 can go to the internet. But it's much easier to define your security policy by what you want to do rather than what you don't want to do. And I will be talking about that later. Okay, so because of that, not only SD-WAN is easy if you keep to the fundamentals, but it's also very much applicable for industrial customers who are looking primarily to hub and spoke topologies and simplify deployment. Let's take an example. You want to run security policy. That's top of mind, as I said before. You want to run a security policy across a number of edge devices. If you want to do that today, even in autonomous mode, you'll have to configure routers manually one by one and maybe use zone-based firewall. Zone-based firewall is good, but there's really no way to manage that from a central place, and it's just, quote-unquote, a firewall. With SD-WAN, we have this next-generation firewall, which gives you a lot of additional benefits. So you can obviously have your normal firewall with your normal rules, but also have a number of things. You can look for signature, you can look for malware, you can do, on the higher-end platform, SSL interception. You can do DNS with Umbrella, so you'll be redirecting all the DNS requests to the Umbrella server. You can do, what is it again here? The malware protection, DNS security, and and the signature malware protection, which is coming from Talos. So we'll be looking for signature and do deep packet inspection. How it works is by using UTD, Unified Threat Defense. In iOS XE, UTD is an IOX application, so SD-WAN will automatically load the IOX application on your router. And once the application runs, all the traffic on the router will be passed through that IOX application, which is the UTD appliance. It's a software appliance that runs all those security checks, security policies. Okay, so one place to configure them, easy tunneling, easy security, central management. But here is the thing, not all customers are ready to move to SD-WAN. They're just afraid, they don't have the time, they're not willing to redesign the network or the way the network is working for SD-WAN. They would like to keep their existing configuration as much as possible, but they love SD-WAN. They love the ability to upgrade iOS XE, to have visibility to their application, to the interface. And that's why we're also introducing along that side SD routing. So you're going to have to pay attention here because it's a detail, but it's very important. SD routing is a subset of SD-WAN. SD routing is SD-WAN without vSmart, without controller, without OMP, without fabric, without tunnels. Essentially, you just keep SD-WAN Manager software, you keep netconf, you keep the YAG models, you keep the lifecycle management, traffic monitoring, everything, but you don't have a fabric. Those routers do not join the fabric. So they are configured very much the same way as they are traditionally configured using CLI. And by the way, it's just running iOS XE autonomous mode. It is not running iOS XE controller mode when you run SD routing. You may also hear about SD-WAN non-fabric. That is the same thing as SD routing. We like to give the same thing multiple names for everyone's entertainment, of course. Okay, so any questions on that? That's very important. And that's one of the new things we've released. Okay, when to use SD routing? This is a question we have often. For me, it's relatively simple. Always use SD-WAN, fabric mode, always. But if the customer doesn't want to move, if they already have an existing configuration they want to absorb and use as it is without changing much, it's possible to do that in SD routing. They don't need segmentation. They don't need auto VPN. They have just like an autonomous router that they just want to see in SD-WAN Manager. But if they still want to be able to see it, to upgrade it, to have visibility on the application status, then SD routing is relevant. So this is really where you should use SD routing. It's a very specific use case in my opinion, but that's an important one because it opens up the door for us to progressively migrate to SD-WAN Manager platform and then to SD-WAN fabric mode in different stages. It's like a stair, and that's an intermediate step between going from nowhere to full SD-WAN, because it can be intimidating, in particular for IoT customers. Okay, we have a number of platforms in the IoT business unit that do support SD-WAN. Contrary to Meraki, we use SD-WAN exclusively for routers, not for switches. The routers we have are the IR1100 01 on the top left, which is made for remote installation. It's DIN rail mounted. As every router in the IoT line, it is fanless, ARM powered, passively cooled, ruggedized, resistant to vibration, dust, and other atmospheric conditions. So it's really made to be installed in a manufacturing plant, in a street cabinet. We see a lot of these in intersections. We also have the IR 1800 on the top right, which is our mobile router. This one has Wi-Fi, dual LTE uplink, PoE, GPS with advanced data reckoning, serial ports. It's also passively cooled. It's also running on an ARM CPU, but it's really made to be mounted in stuff that are moving. Think about ships, boats, ambulance, things of that nature. Then we have the 8340, which is the big beast. This one is kind of a switch and a router. It's a Frankenstein a little bit. It's a switch and a router all together. You have PTP, so IEEE 1588 Grandmaster clock. You have serial ports, you have NIM modules, multiple LTE modules, serial links. So that's the kind of router you will use on large electrical substations when they really need a lot of everything. It's also very resistant to electromagnetic field radiations. So it's really made to be installed in this kind of very unfriendly environment. All right, so for us, for the IoT guys, SD-WAN, because we compared to the traditional management platform that is using CLI or SNMP, we're now using netconf and YAG models. The advantage of a YAG model is that when you tell the router, this is the new configuration, the router, because it's a model, is smart enough to see that's what I have, that's what they want. I can just apply the diff and change the one line or the one IP address between the two. When you manage with CLI, it's always more complicated. Think about just updating access list. Okay, in terms of building infrastructure, we almost always use hub and spoke topology. With traditional management solution, you can manage the spokes, but not the hub, which means every time you add a spoke, someone's gonna go on the hub, add the spoke manually somehow with the pre-shared key certificate. So I know customers have done crazy things like scripts, like Ansible recipe, and things like that to make this happen. With SD-WAN, it's just part of the function. You don't have anything to do. Okay. The ability to isolate the traffic from the transport, from the internet, but also between VPN is very important. In the traditional world, you would route traffic, which means it's open for everyone. It's open bar. Everyone can go anywhere. Then you need to apply access lists to define things that cannot be done. That's counterintuitive. With SD-WAN, you cannot go anywhere unless you explicitly say, this guy can go there. So it's more based on the ZTNA principles. We have, as I showed earlier, we have the concept of zone-based firewall, but also that is applicable to the existing management solution, but only zone-based firewall. With SD-WAN, you have a central place to use unified threat defense. So from a security perspective, that's also a little bit of a game changer. And the last one, which is actually not the last one, it's my favorite one. Think about you have multiple uplinks. You have multiple cellular uplinks. How do you know when the traffic stops working on one of the cellular interface? Traditionally, you would use floating routes. When your cellular interface loses the IP address, the route disappears, and then you use the next best route by order of priority. Problem is, with cellular, when you lose the IP address, you actually probably have already lost all connectivity for 30 seconds before you realize that. So what are our customers doing? They run an IPSLA script that sends ping packets to 88888. And if they see that ping packets doesn't go properly to 8888, then they remove the route to route the traffic to the other cellular interface. I can tell you, the day 8888 will stop responding to ping packets, we will see an internet world outage, because there are so many scripts that do rely on 8888 responding to ping packets. That's going to be horrible. That's what we do in traditional platforms. In SD-WAN, you don't have to do that because we have tunnels. Those tunnels are running BFD, bidirectional forwarding protocol. Every second we're sending a packet. As soon as we stop forwarding traffic on an interface, it doesn't matter the interface is an IP address or not. We automatically reroute the traffic to some other place. And that is a big advantage. It's much cleaner in terms of design. Okay, any questions on that? I will do a quick demo, if that's fine.
I did have one quick question.
Sure.
You said you had the iOS XE handling the core, and then you had the NGFW. So are you actually running a Cisco Secure NGFW virtually and all of that?
Yes.
Or? Very cool. Thank you.
Yes, it runs in IOX, so it's installed as a virtual image in iOS. It runs in IOX, so that's the containerized environment on top of iOS XE. And then the traffic from iOS XE is routed over that IOX container that is managed by SD-WAN with all the policies and everything, and then pushed back to iOS XE. So we actually break down the forwarding path and we push the traffic over to that IOX app.
Very cool. Thank you.
So then that would probably be how like the AMP integrates with that as well. And then it does the malware signature review and stuff.
Exactly what it does. Yep, absolutely. Absolutely. Something we'll need to work on though is that the UTD IOX application right now is taking up all the resources on IOX. As you know, on IOX you can have multiple resource profiles. So you can have small, medium, large, or exclusive. Exclusive eats up everything. UTD, Unified Threat Defense, eats everything. So you cannot run another IOX application if you're running UTD. So that's something we want to work on so that you can use, for example, Cisco Cybervision or Cisco SCA at the same time you're running UTD. Any other questions? All right, let me do a quick demo. I want to show you 4 things. I want to show you, can I do the demo from here? All right, so the first thing I want to show you is how you configure topology in SD-WAN. Say, for example, you have a hub, you have spokes. How do you define what's the hub, what's the spoke? It's going to be very simple. Here you go to configuration. You have a number of things that you can do, like policies and everything, but there's also topology. I have 2 topologies. Let me show you how it works. So you create a topology, you give it a name, and you say the hub is going to be site 101. Every one of the router are part of a site. So you say that site 101 is my hub. You can have one or multiple routers if you want to have redundancy. And the spokes are all those different sites. That's it. That's it. This is the hub. Those are the spokes. Every time you add a spoke to your fabric, the spoke would automatically open an IPsec tunnel to one of the hubs in the site 100 and not establish IPsec tunnels between them because you have only north-south traffic, but you don't have east-west traffic, for example. That's as easy as that. How complicated would that be to do that in a traditional network management platform? Probably a lot more complicated. If you want to do full mesh, it's kind of the same story, except that in full mesh, you have only sites. So you simply add here your number of sites. Here I have site 2, site 4, but I can have 10 sites, and I will have a full mesh between those 10 sites. Obviously, you can also have a custom topology, and you can filter which sites go to the hub and which sites are full mesh. So you can actually mix and match hub and spoke and full mesh topology. But for the purpose of this demo, I just want to show you how easy it is. Then the next best thing is to check the tunnel status. So for example, here I can monitor my devices. So that's the devices that are taking part of my fabric. And there is one which is down here in the world of solution that is currently running out there. And I will show you the tunnel status. So it's an IR 1100 on the Cisco booth in the show floor. I can just ask, hey, show me the tunnel status. And see, now that's probably very small for you, but let me increase the size. You see all the tunnels that this gateway has formed with the neighbors, but also the quality, the latency, the packet loss, the jitter, and all those different information. So forming the fabric is not only very convenient, but it's also very convenient to be able to check the status of your fabric and the quality or the experience for the users. And it's very easy, and it's all here in IoT-OD. Let's say, for example, you want to do security. I can go to Configuration, Security, and I'll show you how you can edit a security policy, and there you have everything. To your question earlier, this is using UTD. So from this one place, firewall, intrusion prevention, including custom rules, URL filtering that you can do. You can do advanced malware protection where the signatures are coming from the Talos security engine. So this thing is directly connected to Talos. DNS security with Umbrella. Only on the IR 8300, you can do TLS SSL decryption. So you inspect the traffic even if it's encrypted. Unfortunately, the IR 1100 and 1800 are not powerful enough to do that. So that is not supported. And you can have a summary of everything you've done. You can also monitor your policies, malware alerts and everything. And the last thing I want to show, because that's the kind of stuff that I like. I am dealing with customer problems every day, all week, all year. And what is amazing with SD-WAN is this ability that whenever you have an edge router in the SD-WAN fabric, because it has a connection to SD-WAN manager using DTLS, we can use that connection the other way around to SSH inside the router. So for example, I have this router out here. I can simply click on the router and it will open up a terminal so that I can type commands and troubleshooting commands on that router. It is very handy, but it's even more handy for IoT where those routers are using cellular, because cellular are usually behind a NAT, a carrier grade NAT. They don't have a public IP address. There is no way on earth I can SSH in those routers if I don't have this, because the connection goes the other way around. So that's super useful. Okay, just a couple of things I wanted to show you how this platform is relevant for IoT. Is there any other question or thing you would like to see?
I'm going to be the one who asks the obligatory IPv6 support question.
So yeah, are you always asking IPv6 questions?
Because I've had 4 deployments in the last 4 months and I've had to kill products that don't support it because they're just not applicable.
So I would say it's partially there. It's not supported for absolutely everything, but it's pretty decent, I would say, at this point. If I have to give you a rating, that would be probably 80% ready. There's just like some of the features are not working. Some of the troubleshooting tools are only looking for IPv4 addresses. If you dual stack, you'll be good. If you're pure IPv6, it can be tricky.
But it's roadmapped. Like
the
plan is to get feature complete.
It's always, IPv6 is always on the roadmap, as you know, right? One way or another. I just can't tell you when.
Fair enough.
All right. Any other question?
Are there any plans to make the equivalent kind of config for SASE?
So the SASE is a bigger story. So if you take SD-WAN and you add SSE, then you have the equivalent of a SASE solution. So it's not just like all part of this, but this is an element of that entire SASE story, at least the Cisco SASE story, which might be different across vendors though.